Hello, my name's Tim McCurrach, and I'm going to be talking to you about what happens when a request comes along and Django needs to deal with that. Now, when we talk about the request response cycle, we could talk about what happens in the browser or the network layer and so on. But for this talk, I'm just going to restrict myself to talking about what happens within Django itself. Furthermore, Django has two means primarily of communicating with a server. There's WSGI, which I'll talk about in a moment. And since Django 2.2, there's also been ASGI, which added support for various asynchronous features. But in this talk, we're just going to talk about the WSGI route. So what is WSGI? Well, it stands for the Web Standard Gateway Interface, and it's just a specification. So it's not a server or a framework, which is a common misconception. It's just a set of rules which says, if you've got a server which adheres to these rules, and if you've got a Python application which adheres to some other rules, well, that Python application is going to run on that server. It's all laid out in PEP 3333, and you can go and read the full details there. So what does our Python application need to look like to be WSGI compatible? Well, it needs to be a callable, and a callable that accepts two arguments. That first argument is going to be a Python dictionary. So when our server gets a web request, it's going to call this function, and it's going to pass in a dictionary containing all of the information you would associate with that request. So there'll be a method, a scheme, some URL information, some query parameters perhaps, and also some additional information about how the server's configured. The second argument is a callback function that I'll talk about in a moment. But beyond that, it's just a callable. You can do anything you like in there, so long as you can write it in Python code. Once you've done what you want your WSGI application to do, there are two more things that the WSGI spec requires. Before you return anything, you need to call this callback function that was passed in as the second argument. And we do two things here. First, we set the status of the response that's going to be sent back to the client. And second, we set the response headers. So that second argument there is going to be a list of tuples with name value pairs. Once we've done that, we're free to return our content, and we must return an iterable that yields byte strings. So you might have wondered, why are we returning a list there and not just returning response as it is? And the reason is because we want to return an iterable. Now, a byte string actually already is an iterable, but if we were to do that, the server would iterate through it and would send back the data one character at a time to the client side. That's obviously not something we want to do. So that's a WSGI application, and Django is, amongst other things, an example of a WSGI application. So how does Django implement this? Well, when you start a new Django project, you'll have a folder structure, something like this, and you'll have this file wsgi.py that you probably ignore most of the time. But if you look inside, down the bottom, we have this line, application equals get WSGI application. So when your server starts up, it's going to import this, and that get WSGI application function is going to run. So let's have a look at what that does. Well, it returns WSGIHandler. Notice we're returning an instance of the WSGIHandler class, and that class instance is the callable. So that's the gateway from server to everything else that happens in Django. So all of those things all start with the call method inside this WSGIHandler instance. Now we know how to make a WSGI application. We could, if we wanted to, replace WSGIHandler with our own WSGI application. There wouldn't be much point in doing that because then you would forgo all the features that Django gives you for free. But in this talk, we are going to write our own WSGIHandler, and the idea is we'll build it back up incrementally until we have something similar to what Django gives us in the first place. That way we'll understand all of the things that Django is doing for us when it handles a request. So here's our first WSGIHandler. We've implemented a call method so that it's a callable, and the rest of the code here is just the same hello world WSGI application we had a few slides prior. Now, obviously, we want to make it a bit better than this. And the first thing we're going to want to do is return more than just hello world. Django is a web framework, so we want Django users to be able to write their own views. We don't have any URL routing yet, so I've got a setting which I'm calling the view, and we're going to import just a function from there and call it. So now already, with just these 6 lines of code, we can actually do quite a lot. We can return some HTML, we could serve up a static page. We have access to things like the ORM, so we could keep track of how many times the page has been viewed, but it's still reasonably limited. We couldn't, for example, have a form on our page because we would need to respond to get and post methods differently. And at the moment, we're not passing any of that information forward into the view, we're just calling it. So one thing that we could do is we could pass in the dictionary we get from the server, and then the view would be able to say, okay, this is a get request or a post request, and it would be able to respond accordingly. However, lots of the information in that dictionary is quite raw, and it would require some decoding and processing that doesn't really belong in the view layer. Of course, we all know the solution to this, which is that every single Django view has a request as its first argument, and it's in the WSGIHandler that this request object is created and passed into the view. Now, I'm not going to go into lots of detail about how the request object is implemented. That's a talk in and of itself, but just so that we can see there's no magic going on here. The idea is we instantiate it with a dictionary, and then we extract out all the pertinent methods, all the pertinent information, and put it in a nice format. So we have these properties for things like query parameters and cookies, and then we have a nice API that we can use in the view to get all of that information in a nice format. So here's our WSGIHandler, and we create a request and we pass it to the view. Django actually implements it slightly differently to that. It sets the request class as a class attribute on the WSGIHandler. And this is one of those details that actually it's really useful to know about, because it means if you wanted to subclass request and maybe add your own methods or tweak the behavior slightly, you could do so, and by setting this a class attribute, we'll use the subclass request. So here's our updated WSGIHandler. Now we can deal with forms. We could use that request object to do some basic URL routing in the view layer if we so wished. But there's still some limitations. We couldn't, for example, return a permission denied response. Why? Well, if we look here, the status is hard-coded, as are our response headers. So we wouldn't be able to do things with cookies, for example. All of this information needs to come from the response. And if you've written a Django view, you'll know what the solution here is. We have this response object that encapsulates all of that information. As with the request, I'm not going to go through it in lots of detail, but just enough so that we can understand what's going on in the handler. So we instantiate our response object with some content, and you might be forgiven for thinking, well, we can just return response.content like so. It's actually a lot more flexible if we make the response object itself the iterable that we return. So how does this work? When we set our content, we store it in a private container attribute, and then we implement this iter method to turn the response object into an iterable. There's a bit more going on there than that, but that's the essence of it. So we still need to deal with this issue of the status. So when we instantiate our response object, we can pass in a status code. And Django also has this nice method which gives us the appropriate phrase that goes with that status code. So, if you pass in 404, it will return not found. And so now in the handler, we can say, well, response.status code, response.reason phrase, and we get that. And likewise, we need to deal with the response headers. And the idea here is by implementing these setItem and getItem methods, we turn the response into a dictionary-like object for storing response headers. So if I wanted to set, for example, the content type response header, I would just write response content type equals text plain. We also have a separate API for dealing with cookies, which does a lot of things automatically for us. And so in our handler, we list those response headers separately. So now we have a handler that can do most of the things that we want it to do, but Django adds a couple of features that it's worth knowing about. Before it does anything else, it dispatches a request started signal. And so we can add that in. And Django uses this internally for things like database connections, but it's actually quite useful for testing as well. So it's worth knowing that it does this. And it would be good to have a request finished signal to go alongside that. And the WSGI spec actually specifies something that makes it easy to implement this. It says if the iterable returned by the application has a close method, the server or gateway must call that method upon completion of the current request. So we can take our response object and we can add a close method, and it means the very last thing that happens after the server sent the response back to the client, this request finished signal will be dispatched. Notice we need to provide a sender, and self in this case refers to the response object. So we'd better set a handler class on the response. So if we go back to handler, we can say response.handler class equals self.class. And now we have something that's actually pretty similar to what Django actually implements. One big difference though is that we are still only returning a single view, and we don't have any middleware or anything like that. Now, I'm going to move that logic into its own function that we can then build out to add some middleware and some URL routing. So an introduction to middleware. The idea here is that our request is going to propagate through the middleware, reach our view, and then the response will travel backwards through the same middleware before finally being returned. How does this work? Well, our middleware wraps the next piece of middleware along, and then when we call it, we can do something useful. Then we pass the request on to the next piece of middleware, and so on. And eventually we get a response back, which we can process and then pass back again. Of course, in the forward direction, as well as passing the request on to the next piece of middleware, we could also return it early, in which case it's never going to reach the view and the response will just travel backwards. So how are we going to implement this? Well, at the moment, the function that we call to get our response is the view. Now, instead of calling that, we're going to build a new function that's going to be the view wrapped by all of our middleware. And this function we're naming handler. And let's see how it's built. Well, we start off with handler just equaling view. And then we loop through each piece of middleware, import it, and wrap the handler. So before our first iteration, handler is just view. After our first iteration, handler is going to be view wrapped by a piece of middleware. And then with each subsequent iteration, it gets wrapped again and again. Notice that we loop through our middleware in reverse order so that the first piece of middleware ends up on the outside. Now this whole block of code here, where we build this function that we eventually call, doesn't need to happen on every single request. The middleware doesn't change, so we can do it just once, and that's a lot more efficient. There's actually a more important reason to do it up front, which is that Django has a philosophy of trying to warn you about things that it can right at the beginning when the server starts up, rather than waiting for a request to happen and then it to error out. So let's move all this code and put it in its own function called load middleware. And then we're going to need to save the function we've made to the middleware chain, or add this attribute middleware chain. Then in our get response function, instead of calling the handler, we're going to call self.middleware-chain. And the only thing that it remains to do is to actually call load middleware. And so we put that in the init method. So this will happen right at the beginning. So here's what our WSGI handler looks like. Now I mentioned earlier that Django tries to warn you about things when it can. So let's add that in. And after we've wrapped each piece of middleware, we'll check that handler is actually equal to something. When we use functions to build our middleware instead of classes, this is a common error. So it's a useful thing for us to check right at the beginning when the server loads up. Now, there's quite a lot that's gone on there, so it's useful to zoom out and see everything that's happening so far. When our WSGI server starts up, it imports wsgi.py. That's going to instantiate a WSGIHandler instance. And so in the init method, we then call load middleware. Load middleware builds self.middleware-chain. And then later on, when a request comes along, the server calls the call method of our WSGIHandler. We make a request object and call getResponse. GetResponse passes that request object onto this function that we've built, middleware-chain. And then we get a response back, which is passed back to the server and then back to the client side. So now we have a WSGIHandler that can deal with middleware, and that's great. But the central piece of the middleware chain handler is still essentially hard-coded to a single view, and we want to improve that. So we're going to replace handler with a function that's going to accept a request, and it's going to look at the URL info in that request and route it to an appropriate view, call the view, and send that response back into the middleware chain. So let's replace handler with a function that's going to do that. Now, in Django, as I'm sure you're all aware, the URLs are normally defined in a file called urls.py, and there'll be a setting called root URL-conf that points Django towards that file. So you might expect here that we're going to import that file, but that's not actually what happens. We look at the request object for a URL-conf attribute. And this is really useful to know because it means we can write middleware that affects how the URL resolution process happens. We might want to have different urls.py files for different types of users, for example. And by setting the URL-conf attribute to a request in middleware, we can do that. So let's have a look line by line at what happens. Well, we see if the request has such an attribute. If so, we call this set URL-conf function. Now what that does is it sets a thread local variable so that all the other functions in Django that need to know which URL-conf we're using will know that. And then we call this getResolver function. As the name suggests, that returns a URL resolver based off the file that we've passed in. If we don't have a request, we just get the standard URL resolver based off the file described in the settings root URL-conf. So once we've got that URL resolver, we call the resolve method, and that's where all the URL resolution actually happens. I'd love to go into that, but that's actually a whole nother talk. The key thing we need to know is that we get back this match object, and the match object will tell us what the arguments and keyword arguments that are extracted from the URL are, what the view function is that our URL has been routed to, some other useful information like the name of the URL. And another line here that's, again, useful to know is that all of that information is attached to the request. So if, for example, you had several URLs all pointing towards a single view, and in that view you wanted to know, well, what's the URL that has resulted in this view being called, you could use the resolver match object to find that out. This next line works because the resolver match object implements an iter method, so we can use the tuple assignment syntax there. But we get callback, which is the actual view function, as well as our arguments and keyword arguments, and then we call that view along with the request and pass the response back into the middleware chain. Now, this whole section of code here is actually implemented in a separate method called resolve request. It's the same code, but it's in a separate method. So I'm just going to update that so that it looks similar to how Django implements things. And so now we have a handler that can do middleware, and it can do some URL resolution as well. And that's great, but there's some additional features that Django adds in, which are really helpful. So when we think about middleware, lots of middleware is used for debugging, and we might want that in our development environment, but not to happen in our production environment. Or we might have some middleware that interacts with some third-party service that we're using, and we want that in the production environment, but not in the development environment. And so you end up with middleware that looks like this. In the call method, we say, well, what environment are we in? Either do something or do nothing accordingly. But it makes much more sense to just not have that middleware in your production environment and not have that middleware in your development environment, depending upon what you want. And Django provides a way of doing this. When it loops through the middleware, when we're building our middleware chain, if a middleware not used exception is called, we just continue and don't add it to the chain. That means we can improve this middleware like so by saying, well, if we don't want to use the middleware in the particular environment we're in, raise the exception and it won't get added to the middleware chain. This also means we can simplify the call method, so we're not having to do that check. Now, one thing that we've not dealt with so far are errors, and any handler needs to be robust and deal with errors well. Django provides us with this useful decorator called convert exception to response. And you can decorate a function, and if an exception happens within that function, what this response for exception does is it says, well, is that a 404 exception? In which case I'm going to return a response with a nice 404 page. Or is it just an exception I don't know anything about, in which case I'm going to return a 500 page, and so on. And so you might think what we could do is we could wrap the entire middleware chain in this convert exception to response. So if an error happens anywhere up and down the chain, it's caught. But let's think about the implications of that for a bit. Supposing we've got a request and it's working its way through our middleware to our view where an exception occurs. The error gets picked up by convert exception to response, and a nice response is sent back. But notice none of the middleware was called on the way back. And this might be bad for several reasons. There might be headers that are set that are required for the browser to even accept the response. From the perspective of someone writing middleware, it's also much simpler if you know that if the first part of your middleware is going to run, then the second part of your middleware is also going to run. And it allows you to write robust middleware a lot more easily. So instead of wrapping the entire middleware chain, a better idea would be to wrap each piece of middleware. So as we build the chain, we wrap each piece of middleware in turn, and we're also going to want to wrap the central piece, the getResponse function. And so this way, it doesn't matter where the exception is raised. We know that if the first part of some middleware has run, the second part of that same middleware will also run. So now we have some slightly better exception handling. Now, one thing we might like to do when we're writing middleware is we might like to know in advance what the view is that's about to be called. But when we're working our way through the middleware on the way in, there's no way we can know this because the URL resolution hasn't happened yet. The solution to this is view middleware. And the way this works is, back at the beginning when we're starting up our server and we build the middleware chain, we check each piece of middleware for a process view method. If it has such a method, we add it to the view middleware list. Then later on, when we're about to call our view, before we do so, we loop through each of these pieces of view middleware. Crucially, at this point, we now know what the view will be, so we pass that in and we can use that information. We don't expect the view middleware to return a response. If it does, we use that response to pass back down the middleware chain instead of the view. But assuming there is no response returned from each of these view middlewares, we continue on, call our view, and then continue as normal. There are two other special methods that we can add to our middleware. One is exception middleware. So this works in a similar way in so much as back when we're building our middleware chain, we check each piece of middleware for a process exception method. If it has it, we add it to an exception middleware list. And what the exception middleware does is when an exception happens specifically inside the view, we loop through the exception middleware to see if it can handle it. If it does and it returns a response, well, that's the response that gets passed back down the middleware chain. Otherwise, we re-raise it and it gets handled by the standard exception handling we talked about earlier. This code actually belongs in its own method, so I'll just change that there. The final special method that we can add to our middleware is template response middleware. So again, when we're building our middleware chain, we check for the process template response method, and we create a list of all our template response methods. And this middleware gets called after we've called the view. Now, some responses can have a special render method, and we use this for delaying the template rendering. So once we've got our response, we loop through each of our template response middleware, and we expect them to return a response because it needs to get passed on to the next piece of template response middleware that's going to run. Once we've looped through all of those, then we call our render method, which is probably going to render a template. And then that's what gets passed back down the middleware chain. Here we also catch exceptions, and if there is an exception, that also gets handled by our exception middleware. Now there's quite a lot of things going on here, so a picture is helpful to see all of this. Our request travels through the middleware, then the URL resolution happens, so we have a view to call, but before we do that, we go through the view middleware, call our view, any exception middleware that needs to be called due to an exception happens, any template middleware that may or may not be called happens, and then we go back down through the middleware again, back to the server. So one more thing that I think it's worth mentioning is that Django has a database setting called atomic requests. And what that setting does is it wraps each view in a database transaction. So we can do that here. We've got a method make view atomic, which I'm not going to go into detail about, but if that setting is on for a particular database, it will wrap the view in a transaction. Notice that even though the setting is called atomic requests, it's just the view, not the rest of the request, that is wrapped in a transaction. So now we've built up most of the core request handling that Django provides for us. It's not exactly the same. There are some bits that I've missed out, some things like checks and logging, and some more significant things like stuff to deal with asynchronous functions, but it's mostly all there. So that's it. I hope you found it some combination of interesting and or useful. And thank you for listening. Saying Emma would like to speak. I'm not sure if there's anything I need to do.
Just call me and I will answer. I was wondering, as a middleware writer, as you mentioned before, is there any other entry point in the middleware that you would like to exist, and that does not exist yet in Django.
Do you mean any sort of additional special methods?
Yes, any additional hooks like I don't know, first response or something like that.
That's a great question, and the answer is I don't really know. I'd not thought of what else I would like to see added. Sorry, nothing immediately comes to mind. But I mean, do you have any ideas of something that you'd like added?
Well, I'm asking because I don't know if you saw my talk, but I did some rewrite of Django, and so I went also through the request response cycle, and I did my middleware handling a bit differently. So, for example, I made sure that that a response object is always passed back to the middleware response with a render method, but that middleware can always act on the response before acting on a rendered response, so that the middleware can always act on a response object. And yeah, it was interesting to look into the middleware, the whole middleware handling in Django. And since I did it a bit differently, I wondered if other people might have had this similar want or need to handle things differently.
Yeah, it's a good question. I'm sorry I've not really got too much to add, but it's definitely something I'll think about. Maybe one for discussion in the Slack channels. Thank you for the question.
You're welcome.
Hello, Tim. Can you hear me?
I can hear you, yes.
So there are a lot of code snippets in your slides, and they were properly marked, and the diffs were good as well. So how do you prepare your slides and prepare your code snippets to show the diffs?
So there's a JavaScript framework I've used called Reveal.js, which describes itself as an HTML presentation framework. So it's all written in HTML, and then Reveal.js sort of makes doing all the animations and things easy. The Git diffs were just a little bit of CSS that's sprinkled on top. I've made my slides available on if you go to the DjangoCon site and click on the talk, there's a link down the bottom, so you can download and see exactly how that's done. But yeah, Reveal.js is what I use to make the slides, basically.
Okay, got it.
Just check the Slack channel for any. Oh.
Hi, Tim.
Hello.
Hello. Thanks for your very interesting talk.
Thank you.
I want to ask if you have studied or deep dive also in the new async part of the six cycle for it start with ASCII and similar, and if you have something you found out better or worse than standard cycle with WSGI.
The answer is no. I've not really done a deep dive into the ASCII handler. I had a very brief look at it, but I'm not sure I could really comment on that. I think so. One thing that the talk doesn't really make clear is the talk that I just did is a lot of the functionality that I was describing wasn't in WSGIHandler. it was in a class called base handler, which is shared by both the WSGI handler and the ASGI handler. So really, it's just that call method that is part of WSGI handler. Everything else is shared between the two. So there's quite a lot in common between the two of them. I missed out lots of code which wraps lots of functions and kind of takes care of both the WSGI and the ASGI side of things. That would be like convert sync to async and functions like that. I don't know if that answers your question. Yeah, I've not really dived into the async side a lot.
Good answer. Thanks.
Got another question. So I just wanted to ask that I've been following the same things that to know what are the different parts of the request response cycle, but not in the framework part, in the web service part. So I just wanted to know that how did you go about in discovering these? Did you look through the code manually? Did you just read the code, or did you run some code and in the debug mode and try to figure out which parts are being accessed and on which response and on which conditions?
So you broke up a bit there in the middle. So just to clarify the question, are you asking sort of how did I go about understanding all of what's going on?
Yes.
Yeah. Okay. I guess it started. I was looking at a couple of tickets to do with the URL routing in the all the Django bugs that you can contribute with, and I was looking at one of those tickets, and from there I was just reading through the code. And that I guess just saying, okay, what does that happen? When does that happen? And so on. I think that's probably what gave me the idea of the talk. Beyond that, when I actually wrote the talk, there were a few things that I wanted to check. So one thing that I did that was quite useful was if there was a line of code which I wasn't sure about why it was done exactly the way it was done, I would look at who committed it, and you pull up the PR, read the comments, go back to the ticket, kind of read all the conversation. And that was actually a really good way of learning about why things were done the way they were done. Because you've got lots of conversation there of lots of people who know lots about Django saying, how about this, how about this? And so you can gain lots of insight by doing that. So that was something I learned a lot of whilst preparing the talk.
That's nice. Thank you.
I'm aware that there's another talk starting all about the Django Software Foundation that looks interesting. I'm happy to hang about if other people have questions, but I don't want people to miss out on other interesting talks as well.
People are dropping off, but I want to say thank you. It was a really interesting talk.
Well, yeah, I'm glad you enjoyed it. Thank you very much.